So there are more examples on Laplace transform now. Okay, we'll be continuing with more examples. We have an example like this. We have a signal which is made up of two signals x of t equal to 3 times e to the power minus 2t ut minus 2 times e to the power minus t ut. Ut, I said ut is a step function. Multiplication of a signal by ut would mean making it one-sided or simplifying its analysis. Okay. So Laplace transform, we have to find the Laplace transform of the signal. You have to find the Laplace transform of this signal. Okay. तो इसका Laplace ढूंढना है. Its Laplace transform would be, we know the Laplace transform general equation is x of s is equal to integration minus infinity to plus infinity. Then this is x of t. Okay. Then e raised to power minus s dt. Okay. Now see, since it is comprised of two different parts, one is this part. This can be considered as part 1, and this is another part in the signal, part 2. Entire Laplace transform can be obtained by applying the principle of linearity, by applying the principle of linearity or superposition, because linearity would mean following the superposition principle. इसका मतलब है पहले पार्ट का हम we will take a separate Laplace transform for part 1 and a separate transform for part 2, since they are algebraically they are uh, subtraction. There are two terms and a minus sign between them. You can keep the same minus sign here, and Laplace transform of first term will be here and Laplace transform of another term will be after that. You can then sum them together to obtain the entire Laplace transform. Now see, you know the entire procedure. We finally were able to obtain Laplace transform for first term is equal to 3 divided by s plus 2. Basically, Laplace transform of e raised power at ut. It is a general form, Laplace transform for this formula. It is equal to 1 divided by s minus a. ठीक है, was 1 divided by s minus a. This is the general formula, आपने पढ़ा भी होगा. So once we have obtained for part 1, that is why we have 3 divided by s plus 2, because a here is equal to minus 2. For second part, Laplace transform is 2 divided by s plus 1. 2 divided by s plus 1. Okay. 2 divided by s plus 1. Okay. Now see, once we so we can analyze here. There are, if we rearrange this equation, there will be something in the numerator. Okay. If we rearrange this equation or further simplify this equation, this will be multiplied by this one, and this will be multiplied by this thing. Then you can take LCM, and finally, x of s will be equal to this thing, or x of s is equal to s minus 1 divided by s plus 2 into s plus 1. Okay, s plus 1. अब देखिए, for this Laplace transform, how many poles we have? Afnan, how many poles do we have in this equation? Afnan is here.
Yes, sir. Yes, sir.
How many poles do we have for this Laplace transform?
Sir, poles दो होंगे sir.
Which pole? What is the value of the pole?
Sir, sir वो निकालना है sir.
हाँ बताओ कैसे, हमारे पास तो है.
जो नीचे है ना ये सर क्वाड्रेटिक इक्वेशन, इसको सॉल्व करेंगे सर. जो इसके जीरोस होंगे सर.
हाँ, इसको सॉल्व करके हमारे पास इसके रूट्स मिले s plus 2 and s plus 1 into s plus 1. These are the roots.
Yes sir.
So what will be the pole now for this x of s?
सर इसका पोल होगा सर एक सर -2 और
हाँ, s plus 2 equal to 0.
yes,
So
s
that
plus
would
2
mean
equal
s equal to -2. Now
and
see, you have okay, ठीक है बेटा. So we have two poles, s equal to -2 and s equal to -1. But we also have a 0. ठीक है, s equal to +1 जो न्यूमरेटर में है. So अब अगर इसका region of convergence देखेंगे, region of convergence is always decided by the poles. And I said yesterday also, if you have two poles, then the rightmost pole will decide the region of convergence. ठीक है, तो इसमें एक पोल तो यहाँ है, -2 पे, और एक पोल है -1 पे। इसका रीजन ऑफ कन्वर्जेंस जो राइट मोस्ट पोल है वहां से स्टार्ट होगा। ओके, वहां से स्टार्ट होगा। फिर जहां तक बात रही अब जीरो की, जीरो इज समवेयर हियर। नाउ सी, जीरो कैन बी इनसाइड region of convergence. There is no issue with that. We have only issue with poles. Poles can never be in region of convergence. Lekin as zero, it is possible for a Laplace transform that its zero can lie within the region of convergence. So S is the zero lies at 1. That is why we have marked a zero here. ठीक है, तो हमने यहाँ पे mark किया है. The second thing you have to note here is that imaginary axis is always within, it is also in this question, it is also in this problem, it is also within region of convergence. There is a significance for that. Okay, there is a significance if the imaginary axis lies within region of convergence or outside region of convergence. We can extract some information from that also. That will be discussing in coming slides. ठीक है, जब imaginary axis region of convergence में होती है, उसका क्या मतलब होता है वो हम आगे discuss करेंगे. But please remember that zeros can be in the region of convergence, and if you have two poles, then the rightmost pole will always determine the region of convergence. Okay, region of convergence. Okay. So generally we say all causal systems have right-sided region of convergence to rightmost pole. All causal systems, जितने भी causal systems होते हैं, उनका generally जो region of convergence होता है, it is right-sided, and it is right-sided, rightmost to the right side to the rightmost pole. जो rightmost pole उनका होता है, जैसे यहाँ -1 is the rightmost pole, उसके right side में होता है. ठीक है. अब देखिए कभी कभार what is this importance of region of convergence? Sometimes region of convergence can be in this form. जैसे पहला है हमारा, ठीक है, इसमें अगर आप देखोगे, you have region of convergence, it is right to the rightmost pole, and imaginary axis is within the region of convergence. Sometimes region of convergence can be between two poles, only between two poles. It is a form of strip. Okay, in that case it is a form of strip. ऐसा भी हो सकता है कभी कभार. Region of convergence, sometimes it can be to the left of the leftmost pole. It is also possible that it is left of the leftmost pole. Okay, so this is right of the rightmost pole, and this is left of the leftmost pole. And sometimes this region of convergence can be between two poles, then it is a strip. That is also possible. आपको ऐसे भी examples मिलेंगी जिसमें ऐसा होता है. ठीक है. Now see, it is important to note that if the region of convergence contains j omega axis, if the imaginary axis is within the region of convergence, then we say system is stable. तब हम कहते हैं system is stable. So in this case, if you will see, this system is stable. Okay, this one is stable. This one is stable because the region of uh, convergence, it comprises imaginary axes. And what are for causal linear time invariant systems, for causal linear time invariant systems, the region of convergence is right side to the rightmost pole. You just have to remember them. अगर आपको numerical आएंगे ऐसे ही, identify the stable system, तो आपको देखना है पहले कि किसमें imaginary axis है. That would be the first step to do. और अगर आपको पूछा जाएगा which one is the causal linear time invariant system, you have to find the region of convergence जिसका right side to the rightmost pole होगा. That will be your causal linear time invariant system. And for stability of causal linear time invariant systems, all the poles should lie on left half side of the S-plane. हम generally कहते हैं the poles should always lie on the left half side of the plane, left half side of the S-plane. If they are on the right hand side of the S-plane, then the system is not stable. ठीक है, इसमें हम आगे I'll give you more explanation with examples, but I'm just mentioning it. For the stability of a causal linear time invariant system, ठीक है, all the poles should lie on left half side of S-plane. For example, here in equation in graph 1, in graph 1 you say that you can observe the poles are on right side or left side. Okay, the poles are on left side, they are on left hand side of the S-plane or region of convergence. Okay, they are on left hand side. एक तो वो left hand side of the S-plane में है, और वो रीजन ऑफ कन्वर्जेंस में भी नहीं है, और इमेजिनरी एक्सिस भी आपके रीजन ऑफ कन्वर्जेंस में है. सो दैट विल डिटरमाइन द स्टेबिलिटी. For anti-causal linear time invariant systems, the region of convergence is always left side of the leftmost pole. So this one is basically anti-causal. This is causal system. ठीक है, इसमें और उसमें यही फर्क है. For anti-causal linear time invariant system, the region of convergence is left side to leftmost pole. And for stability, for the stability of anti-causal linear time invariant system, all the poles should lie on right hand side of the S-plane. Okay, they should lie on the right hand side of the S-plane. They should lie on the right hand side of the S-plane. Okay. Now see, we can further have discussion on these causality and stability uh, topic. We'll take them. We'll take this discussion in examples. If हम examples करेंगे, I'll elaborate there more. So we can have more examples for Laplace transform. ये आपकी book में से है, text book में से है, Simon Hacken से. The question could be determine the Laplace transform and region of convergence of the following signals. See, initially you had u of t. You had u of t. Now you have u of t minus uh, a. It is u of t minus 5. I will discuss the properties of Laplace transform. उसमें मैं आपको बताऊंगा how to solve these problems, but they are very easy. I have also given you an introduction of unilateral Laplace transform. I said that Laplace transform are bilateral. They can be bilateral and they can be unilateral also. And I said that bilateral Laplace transform, they are observed in left half, in the negative half of the axis also, and in positive half of the axis, from minus infinity to plus infinity. लेकिन जो unilateral Laplace transform है, the general equation for that is, you can notice here what is the difference. It is all about units. Okay, sorry, limits. So it starts from zero, minus means zero, to infinity. तो ये सिर्फ plus half में ही evaluate किए जाते हैं. And these Laplace transforms are very easy to analyze. They are very easy to analyze. So generally हम u of t को multiply करते थे. अगर हमारे पास bilateral Laplace transform होता था, we used to multiply it by u of t, a step function, in order to make it more simpler or to look like a unilateral Laplace transform. But this is the general equation, general expression for unilateral Laplace transform. Okay. तो इसी तरीके से you have certain examples on it also. मैं ये I would like to discuss certain properties जिसमें ये चीजें मैं I would definitely discuss it here. We have an example of a unilateral Laplace transform, for example. Okay, so this Laplace transform here, x of t consists of three terms. This is one term, term number one, term number two, term number three. ठीक है, ये भी एक सिग्नल है, इनपुट है, but it comprises of three terms. When we take its Laplace transform, you know that how we take the Laplace transform of a signal which can follow the linearity principle. इसमें आप पहले डेल्टा टी का अलग देखोगे, Laplace transform उसका 1 है. Then you will take Laplace transform of second term, that will be probably this thing. Okay, Laplace transform of a times e raised to power at, it is equal to, this is general form, it is equal to a times 1 divided by s minus a. Okay, s minus a. So this is the general form. So you can apply it here. आप इसको कर सकते हैं apply. तो second term की Laplace transform आपको मिलेगी. Then you can similarly find the Laplace transform of third term and you can combine them together. फिर आप इसको solve करेंगे and you will be able to find that there are two poles. There are two poles and two zeros in this Laplace transform x of s. Okay, तो इसको भी वही चीज, suppose you have one pole is at s equal to 2. ठीक है, एक तो है 2 पे, दूसरा है -1 पे. तो राइट मोस्ट पोल विल डिटरमाइन द रीजन ऑफ कन्वर्जेंस. ठीक है, तो वो ये होगा, राइट मोस्ट पोल मीन्स 2, और आपको दो जीरोज है. दो जीरोज मीन्स concentric circles. Concentric circles means you have two zeros at same point. Okay, this is how we can determine them. I'll take properties. I'll shift to properties of Laplace transform. So properties of Laplace transform. The first property of a Laplace transform is linearity. Okay. What is linearity? A system is said to be linear if it satisfies the superposition property. Okay. एक system को linear तभी कहा जाता है when it satisfies superposition property. Superposition property means if you have two different terms, you can act upon each term independently, then you sum the effect of the two, it will be equal to a combined effect. So ये combined effect है. So what I mean to say by this is that if we have two signals, one is x1 of s, ठीक है, तो हमारे पास अलग दो सिग्नल्स है, एक है x1 of s, इसका हमने लेप्लास ट्रांसफॉर्म निकाला, इट विल बी this x1 of, sorry, we have one signal x1 of t in time domain और उसका लेप्लास ट्रांसफॉर्म है x1 of s, तो ये एक अलग सिग्नल है. एंड वी हैव अ सेपरेट सिग्नल x2 of t, ठीक है, उसका हमने लेप्लास ट्रांसफॉर्म निकाला, इट इज x2 of s. Suppose region of convergence for first signal is R1 and region of convergence for second signal is R2. If we combine these two signals, we will obtain a new signal, x new of t. What will be x new of t equal to? It will be equal to x1 of t plus x2 of t. ठीक है, अगर हम लेप्लास ट्रांसफॉर्म ऑफ x new of t ढूंढेंगे, if somebody will ask me what will be the Laplace transform of x new of t, so it will be based on linearity principle, because Laplace transform, they follow the linearity principle. It will be superposition of two Laplace transforms, that is x1 of t का अलग Laplace transform निकालेंगे और उसका अलग निकालेंगे, ठीक है. So that is shown here in this statement. If you have a signal which is summation of two signals, now a and b are constants, you can remove them, it's not necessary, a and b are constants, so let us include them here for sake of argument. A times x1 of t plus b times x2 of t makes a signal which is a new signal, uska Laplace transform hoga individual Laplace transform of each component. Okay, तो उसकी एग्जाम्पल अगर आप कहेंगे प्रैक्टिकल एग्जाम्पल, सो इट विल बी, प्रैक्टिकल एग्जाम्पल वुड बी, for example, if we have to find Laplace transform of cos theta or cos 80, okay, cos 80, you know that cos theta is equal to 1 half of e raised to power 80 plus e raised to power minus 80, okay, e raised to power plus theta and e raised to power minus theta. Then since it consists two exponential terms, ठीक है, अगर इसका आप लेप्लास ढूंढेंगे, लेप्लास ऑफ दिस एंटायर थिंग, वो हमें it will be superposition of two. Okay, so this is term 1 and term 2, आप इनका अलग अलग देखेंगे, then you can find the Laplace transform. That is what I was saying in the previous example. वहाँ पे delta of t था और एक दो terms थी, term 1, term 2, term 3. मैंने कहा था कि I said that you have to find the Laplace transform of each term individually, then you can combine them. I said that on the basis of linearity principle. Okay, linearity principle. And it is said that region of convergence, please note it, region of convergence for such systems, it will be intersection of two region of convergence. Intersection means common area of two, common portion of two region of convergences. Sometimes it results in a strip also, जो अभी हम डिस्कस कर रहे थे. ठीक है, कोई किसी को कोई सवाल तो नहीं है? बुशरा को कोई सवाल तो नहीं है? बुशरा, आपको बेटा सवाल तो नहीं है?
No, sir.
मोमिन, इज इट फाइन? लिनियरिटी प्रॉपर्टी,
Yes, sir.
कोई सवाल तो नहीं है बेटा आपको?
No, sir.
व्हाट अबाउट फरहत,
No, sir.
अबरार? ओके, अबरार इज बिजी, यू कैन लीव हिम. तो दूसरी प्रॉपर्टी है, the second property is time shifting property. Okay, time shifting property, I forgot to change it, just a second. The second property is time shifting property. Time shifting property. Now see, in time shifting property, if we have a signal x of t, ठीक है, एक सिग्नल है हमारे पास which is x of t, this is my signal x of t. we know that its Laplace transform is x of s and its region of convergence is R. Its region of convergence is R. Now, if we shift this signal by time domain, in time domain, if we shift it, that means if we replace t by t minus t naught, अगर हम इसको shifting करेंगे, time shifting, it is as good as multiplication of e to the power minus st naught in Laplace domain. It is as good as multiplication uh, uh, of its Laplace transform by e to the power minus st naught in Laplace domain. Okay, and please note that region of convergence remains unchanged, does not shift. तो जब भी हम टाइम शिफ्टिंग करेंगे किसी सिग्नल को, इसका लेप्लास ट्रांसफॉर्म जरूर चेंज होगा, इसका लेप्लास ट्रांसफॉर्म जरूर चेंज हो सकता है, बट रीजन ऑफ कन्वर्जेंस डज नॉट चेंज. ओके, so we have an example here. This is basically inverse Laplace transform general equation. Okay, this is basically inverse, this is inverse Laplace expression. Why? Because Laplace expression में, Laplace transform expression में हमें मिलता है x of s आउटपुट में, and that we know it is equal to minus infinity to plus infinity. X of t is input signal, and then you have e raised to power minus st dt. Okay, तो ये है Laplace transform की equation, but this is inverse Laplace transform equation. So suppose in this equation, if we are replacing it by t is replaced by t minus t naught, okay, then you can simplify this equation. You know that we have replaced t by t naught. Wherever there is t, it is replaced by t minus t naught. ठीक है, खाली t को ही replace किया, and we will be able to find that we will be having something this. Okay, तो हमें ये we are separate. Yes, if you have any question, Mumin को कोई सवाल है?
सर जो x of s है ना वो x of t है, इसकी फंक्शन एक ही है ना सर?
आप एक बार दोबारा बोले, I cannot hear you clearly.
Laplace of x of s जो है और इंटीग्रेशन ऑफ माइनस इनफिनिटी टू प्लस x of t जो है, x of t और x of s
Please
की
keep your
फंक्शन.
mic away. Please keep your mic away from your mouth. थोड़ा दूर रखें. Please speak up.
तो जो है x of t है ना,
हाँ,
इसकी फंक्शन और x of s की फंक्शन सेम होगी ना सर?
x of t की और x of s की फंक्शन सेम है, यही आप बोलना चाहते हो?
जी सर.
See, x of s is basically Laplace transform. It is in s domain. It is a signal in s domain.
क्योंकि सर अगर हम लेप्लास में देखते जनरल फार्मूला, अगर हम लेप्लास की बात करें, हम करते हैं लेप्लास ऑफ x of t वो होता है बराबर इंटीग्रेशन ऑफ 0 टू इनफिनिटी e टू द पावर x into dt.
हाँ, लेकिन वहां पे ये टर्म नहीं है, वहां पे ये टर्म नहीं है, और यहाँ पे माइनस है वहां. ठीक है, वहां ये तो नहीं है ना, तो ये तो डिफरेंट है ना, इतना तो बेटा डिफरेंट है, वहां ये टर्म्स तो नहीं है, तो इट इज डिफरेंट. ये वो नहीं है. ये देखिए, x of t एंड x of s कैन नॉट बी सेम हियर, क्योंकि यहाँ कुछ टर्म्स एक्स्ट्रा है जो इसको डिफरेंशिएट करती है, इसकी एक्सप्रेशन को. जैसे हमने फोरियर ट्रांसफॉर्म और इनवर्स फोरियर ट्रांसफॉर्म में बताया, बिकॉज यू हैव 1/2 pi j here and you have e raised power plus s, while as in Laplace transform you have e raised power minus s. Okay, तो इसमें फर्क है. So we are separating terms from e raised power t minus t naught में हमने separate किया. We have one term here and another term here. Okay, then you can finally see that, आप इसको देख सकते हैं. If you observe now, आप कह सकते हैं इसको that just a second. You can see that just a second. Okay, now see, I will mark this equation as equation A and this is equation B. Okay, if you compare equation A and equation B, you will see that here in this expression you have x of s. ठीक है, यहाँ x of s है, और यहाँ है e to the power minus st naught x of s. ठीक है, बाकी टर्म सेम है. I said that is an inverse Laplace expression. So this is also an inverse Laplace expression. ठीक है, ये भी एक inverse Laplace expression है. अब ये inverse Laplace जो equation A है, वो किसका लेप्लास लेती है? वो लेती है इनवर्स लेप्लास, आई विल से इनवर्स लेप्लास इज इक्वल टू L टू द पावर -1। वो लेती है इसका x ऑफ s का, और देती क्या है आपको? वो देती है आपको x ऑफ t। ठीक है, इक्वेशन ए। वाइल एज जो इक्वेशन बी है वो लेती है इनवर्स लेप्लास किसका? x ऑफ s into e raised power minus st naught and gives us x of t minus t naught. ठीक है, so it is because they are dual pairs also, Laplace transform and inverse Laplace transform, they are dual pairs to each other, dual to each other. Okay, so it is a Laplace inverse Laplace transform pair. It means that if you take Laplace of x of t, उसको आपको मिलेगा x of s, लेकिन अगर आप इसको वापस इनवर्स लोगे, अगर आप उसका वापस इनवर्स लोगे, ठीक है, तो आपको मिलेगा x of t। ठीक है, तो इसी तरीके से बाय सेम आर्ग्यूमेंट आई कैन से हियर दैट इट वाज बेसिकली t माइनस टी नॉट हियर, t माइनस टी नॉट। तो अगर हम लेप्लास अब लेंगे t x ऑफ t माइनस टी नॉट को, तो आपको मिलेगा ये वाला टर्म। दैट इज व्हाई आई सेड दैट टाइम शिफ्टिंग प्रॉपर्टी सेज, टाइम शिफ्टिंग प्रॉपर्टी सेज दैट time shifting property says that Laplace of a time shifted signal, it is as good as multiplication of Laplace by e raised power minus st naught. Okay, e raised power uh, st naught, e raised power minus st naught. So that is okay, cannot mark it, that is here also. ठीक है, ये किसी को इसमें सवाल तो नहीं है? मे बी महविश, महविश आपको बेटा समझ में आया?
Yes, sir.
कोई सवाल तो नहीं है इसमें?
No, sir.
What about तरुबा?
Yes, sir.
ओके, तरुबा आपको समझ में आया बेटा?
Yes, sir.
रिहा आपको समझ में आया? 77
Sir.
आपको कोई
सर
सवाल तो नहीं है? हाँ, अफनान को कोई क्वेश्चन है?
इसे थोड़ा सा रिपीट कीजिएगा सर। सर मेरे को थोड़ा शोर आ रहा था सर, नेटवर्क में थोड़ा
कहाँ
प्रॉब्लम
से
था
रिपीट करना है आप बताओ?
सर। प्रूफ से थोड़ा सा।
प्रूफ से? अच्छा,
जी सर।
प्रूफ बहुत इजी है। हमने इनवर्स लैप्लास ट्रांसफॉर्म की इक्वेशन ली, जिसको हमने कहा इक्वेशन ए। फिर हमने उसमें जहां जहां टी है उसको हमने मल्टीप्लाई किया बाय, जहां जहां उसमें टी था हमने उसको मल्टीप्लाई किया, जस्ट अ सेकंड, आई चेंज द कलर। ओके, जहां जहां टी था, ओके, आई हैव टी इज हेयर, समवेयर हेयर टी इज हेयर इन इक्वेशन ए, हमने इसको टी को किया टी माइनस टी नॉट से चेंज, तो यहाँ पे भी चेंज होगा, ओके, और यहाँ पे भी चेंज होगा। फिर हमने टर्म्स को सेपरेट किया, ई रेज्ड पावर एस टी माइनस टी नॉट को सेपरेट किया, तो हमें आएगा ई रेज्ड पावर एस टी, पहले वो है यहाँ, दूसरा आएगा ई रेज्ड पावर एस माइनस टी नॉट माइनस एस टी नॉट, वो आएगा यहाँ पे। फिर हमने इक्वेशन ए और बी को कंपेयर किया, ठीक है, इक्वेशन ए और बी को कंपेयर किया। Once we compared equation A and B, we said that B is also inverse Laplace. It looks like an inverse Laplace expression. और उसमें हमने देखा Laplace इनवर्स Laplace एक्सप्रेशन, जो एक्सप्रेशन नंबर A है, वो इनवर्स Laplace निकालती है x of s का, और ये निकालती है e to the power minus st naught x of s। तो यहाँ हमें मिलता है x of t minus t naught, और यहाँ मिलता है x of t, तो हमने कहा Laplace of x of t minus t naught is then e raised power minus st naught x of s। okay, x of s, that is what I said। आप दोबारा वीडियो देखिए, मैं इसका अपलोड करूंगा वीडियो, and you can then find out this। okay, now properties of unilateral Laplace transform, properties of unilateral Laplace transform, these are basically all properties of unilateral Laplace transform। ठीक है, जो मैं ये बता रहा हूँ आपको, दे आर प्रॉपर्टीज ऑफ यूनिलेटरल लेप्लास ट्रांसफॉर्म, टाइम शिफ्टिंग वगैरह जो भी है, या लिनियरिटी वगैरह। a shift of a shift of tau in time, or it is basically t, a shift of t in time corresponds to multiplication of Laplace transform by complex exponential e to the power minus st। so this is basically just a second. Okay, whatever I am saying here in point number 1, तो point number 1 में बताया जा रहा है ये असल में मैं ये कह रहा हूँ कि any shift in t, a shift of t in time corresponds to the multiplication of Laplace transform by complex exponential e to the power minus st. Okay, minus st. And this property applies only if the shift does not move a non-zero t greater or equal to zero component of signal to t less or equal to zero. ठीक है, मैं इसको समझाऊंगा. Or does not move a non-zero t less than equal to portion. All right. Now see, ये कहता है टाइम शिफ्ट प्रॉपर्टी जो है, जो मैंने ऊपर एक्सप्लेन की है. We have two cases here. Okay, we have two cases here. In first, a non-zero portion in part A. This is your part A. Okay, this is your part A. In part A, in figure a non-zero portion of x of t that occurs at time t greater or equal to 0. See, this is the non-zero portion. Just a second. This is the non-zero portion. ठीक है, ये एक सिग्नल का नॉन जीरो पोर्शन है, ये एक सिग्नल का नॉन जीरो पोर्शन है which occurs at t greater or equal to 0, and if it is shifted to. Yes.
सर शोर बहुत आ रहा है.
शोर बहुत आ रहा है.
यस सर.
हर किसी बच्चे को सेम प्रॉब्लम आ रही है. अफनान, मुदस्सिर बेटा, आप लॉग आउट करो एक बार और दोबारा ज्वाइन करो. ठीक है,
ओके सर.
ओके. तो हमारे पास एक सिग्नल है x ऑफ t. इसमें राइट साइड से अगर आप देखोगे t ग्रेटर और इक्वल टू 0, देयर इज सम नॉन जीरो कंपोनेंट. देयर इज सम नॉन जीरो कंपोनेंट. ठीक है, देयर इज सम नॉन जीरो कंपोनेंट. नाउ सी, इफ आई शिफ्ट इट टुवर्ड्स लेफ्ट साइड, इफ आई शिफ्ट इट टुवर्ड्स लेफ्ट साइड. अब टाइम शिफ्ट करना है. अब मैंने इसको टाइम शिफ्ट किया. वी कैन गो फॉर ए राइट शिफ्ट और ए लेफ्ट शिफ्ट. जब हमने टाइम शिफ्ट इसको लेफ्ट साइड से किया, आप देखिए जो ये नॉन जीरो पोर्शन है, ये आपको यहाँ पहुंचा. ठीक है, ये आपको यहाँ पहुंचा. सिमिलरली इन पार्ट बी, a non-zero portion x of t that occurs at time t less than 0. ठीक है, t less than 0. तो आपको एक यहाँ पोर्शन था सिग्नल में, वो t less than 0 पे हो रहा था ऑकर. ठीक है, और जब आपने इसको राइट शिफ्ट किया, तो प्लीज नोट, इन पार्ट ए वी आर गोइंग फॉर ए लेफ्ट शिफ्ट एंड इन पार्ट बी वी आर गोइंग फॉर ए राइट शिफ्ट. तो इस राइट शिफ्ट में आपको ये पोर्शन यहाँ पहुंचा. लेकिन जब आप सिग्नल को एनालाइज करेंगे, ठीक है, इस सिग्नल को, इफ यू एनालाइज दिस सिग्नल, इसमें और इसमें फर्क है. इस सिग्नल में और इस सिग्नल में फर्क है. अगर शिफ्ट, टाइम शिफ्टिंग ऐसे हुई कि इसने सिग्नल का कुछ पोर्शन ही, इंफॉर्मेशन ही चेंज की, इसने कुछ पोर्शन इंफॉर्मेशन जो है एक सिग्नल की, वो इसने बिल्कुल रिमूव की, then this shifting property is not applied to that kind of signal. ठीक है, उस सिग्नल में ये नहीं है. उस चीज में ये एप्लीकेबल नहीं है, क्योंकि इसका एक अच्छा खासा पोर्शन रिमूव हो गया है. आप ये कर सकते हैं, इमेजिन दैट सिग्नल इफ इट स्टार्ट्स फ्रॉम हियर, फॉर एग्जांपल फ्रॉम हियर, एंड यू विल गो फॉर अ राइट शिफ्ट, it will be shifted towards more right, then it can be applied. लेकिन ऐसे शिफ्ट में जिसमें आपकी सिग्नल बिल्कुल उसकी इंफॉर्मेशन लूज होगी, in that case this property may not be applicable. ठीक है, तो ये प्रॉपर्टी उनमें एप्लीकेबल नहीं है. There is another one. I'll go for scaling first. ठीक है, properties of Laplace transform. Another property is scaling property. I'll continue for a few more minutes, then I'll stop. Scaling theorem provides that if you horizontally stretch a signal, okay, if you horizontally stretch a signal by a factor of alpha or a in time domain, you squeeze its Laplace transform by the same factor in S domain. Okay, what is stretching? Stretching means, so you have a signal here. ठीक है, आपके पास एक सिग्नल है, ये ऐसी है. सो स्ट्रेचिंग वुड मीन यू आर मल्टीप्लाइंग इट बाय सम नंबर, टाइम डोमेन में. अभी तक थी ये t इक्वल टू 1 पे, और दिस इज -1 एंड दिस इज 1. ठीक है, अभी तक ये यहाँ तक डिफाइन की गई थी, t इक्वल टू -1 एंड t इक्वल टू +1. आपने अब इसको स्ट्रेच किया, you multiplied its time by, for example, 2. So 2 into -1 and 2 into +1, it will be equal to -2. अब ये एग्जिस्ट हो रही है -2 से और हो रही है +2 तक. अब इसको स्ट्रेच किया आपने. ओके, so if you stretch a signal horizontally, if you stretch a signal horizontally by a factor of a, so a here is equal to 2. A here is equal to 2 in this example in time domain. Then you squeeze its Laplace transform by the same factor in S domain. S domain में इसका जो Laplace transform होगा वो squeeze होगा. Squeeze का मतलब वो और छोटा होगा by the same factor. Okay, in S domain में इसकी squeezing होगी. Now, mathematically, we can express this scaling effect as x of t. See, initially I was x of t I was having x of t. X of t is a signal. ठीक है, उसका जब हमने Laplace transform निकाला, Laplace transform, it will be x of s. It is x of s. Okay, it is x of s. Now see here, once you have obtained or you have operated it, you have scaled it by a in the second step. दूसरी step में हमने क्या किया, हमने इसको scaling की a times. Its Laplace transform will be squeezed. Squeezed मतलब इसको divide होगा s by a. S by a. So Laplace transform is 1 by a times x of s by a. Okay, for a greater than 0. For a greater than 0. I think I should have some example for that also. Scaling. Okay, proof for this. Proof. Let me discuss the proof and I'll stop then. How we can prove this? See, I have a signal. Okay, just a second. I have a signal which is f of 80, which is f of 80. I want to find the Laplace transform of f of 80. Laplace transform of f of 80, since this is a unilateral Laplace transform property, these properties all belong to unilateral Laplace transforms. So our limits will be from 0 to plus infinity. Okay, and you know this much is here x of t. This is basically x of t. Okay, so my x of t here, it is equal to f of 80. So we want to find the Laplace transform of it. In order to find the Laplace transform, let us first try to simplify it. We put z is equal to 80. Okay, z is equal to 80. In that case, t will be equal to z by a, and dt will be equal to dz by dA if you differentiate it both sides. Okay, differentiating. So if now t will be equal to 0 or t will approach to 0, what will be the value of z? So t here from this equation A, t can be 0 only when z is equal to 0. ठीक है, अगर a होगा 0, then it will be t will be infinity. Okay, t will be infinity. So here in equation A, t is directly proportional to z. If z will approach to 0, z का value अगर 0 होगा, then t will be 0. If z is infinity, then t will be infinity. That is how the limits will be modified. Okay, so apparently there will be no change in limits because they are directly proportional. Z and t are directly proportional. Now the Laplace transform of f of 80, which is basically Laplace transform of z, it will be equal to integration 0 to infinity e raised power minus s. Instead of t, you will use expression a. So z by a banega, then fz dz by a. Okay, dz by a. Now dz by a में से 1 by a बाहर आएगा, so that will be here, and you are left with e to the power minus s by a into z f of z dz. Okay, now you see this expression. Now this expression, it is a general expression of Laplace transform. ठीक है, तो Laplace transform, it is the general expression of Laplace transform. And here in Laplace transform general equation, you had Laplace transform of x of t, it is equal to integration minus to infinity, yeah, 0 to plus infinity, x of t into e raised power minus s t. देन इट इज dt। ठीक है, अब देखिए यहाँ इन इक्वेशन बी, प्लीज कोरिलेट इट विद इक्वेशन बी। इक्वेशन बी में आपको dz है dt के बदले, उसमें कोई प्रॉब्लम नहीं है। x of t के बदले आपको f of z है, देयर इज नो प्रॉब्लम, दैट इज क्वाइट सेम, ओके। बट इंस्टेड ऑफ e raised to power minus st you have e raised to power something into z, that is quite logical, but s यहाँ modify हुआ है। s instead of s you have s by a, s by a। ठीक है, तो जो आपको मिलता था x of s, लेप्लास ट्रांसफॉर्म ऑफ x of t, आपको मिलता था x of s, अब आपको मिलेगा x of s by a, because you do not have s now, you have s by a, that is why you have s by a in the formula here। ठीक है, और 1 by a कहाँ से आया? 1 by a will be taken out from here, कि जो यहाँ है, because there was, it is dz into 1 divided by a, that is what is known as dz by a। तो 1 by a times x of s by a। I'll stop here, अगर किसी को कोई सवाल है आप पूछ सकते हैं, otherwise I'll stop। कोई सवाल है किसी को?